Today we're going to complete number 8 on the study guide for the energy test. So we have a roller coaster, and remember that on a roller coaster the most important thing to remember is that the total energy will not change once you've found it. So let's find a place where we know the total energy. That is, we know potential and kinetic. The only place where we know both velocity and height is that place. So we're going to start there. To find potential energy, we need the equation for potential energy. U equals mgh. The mass, 60 kilograms. Gravity is 10 meters per second squared. And the height is 5 meters. When you do all that, you get 3,000 joules. Okay? For kinetic energy, we need the equation for kinetic energy, which is 1/2 mv squared. Plug in all the numbers. And well, 0 squared is 0, and anything times 0 is 0, so the kinetic energy is 0. That means that the total energy of this roller coaster car is 3,000 joules. Once the car is released from the highest hill, that 3,000 joules has to be the same no matter where the car is. So the total energy, say at point B, has to be 3,000 joules. At point C, the total energy has to be 3,000 joules. Same with point E. You can't get away from that. This is good though, because if I can find, for instance, potential energy at any spot, all I have to do is subtract to find the kinetic energy. So let's find the potential energy at point B. We'll have, I'm going to leave the units out now just for expediency. mgh, which when you put that in your calculator becomes negative 1,320 joules. Yes, you can have negative potential energy. To find the kinetic energy, I know that total energy is what you get when you add up both energies. So kinetic energy must be total energy minus potential energy. So in this case, 3,000 minus a negative 1,320. When you subtract a negative number, that's kind of like adding. So this is going to be 4,320. For velocity, I know that kinetic energy equals 1/2 mv squared. If I were to solve that for velocity, I could multiply both sides by 2. Can divide by m. So now I have 2k over m equals v squared. And then I have to square root both sides. So v is going to be the square root of 2k over m. If I put all the numbers in for this problem, v ends up being 12 meters per second. We'll leave that as an exercise for the viewer. No one will get that joke. All right, let's continue. So here, I'll use this h to find the potential energy, which is going to be 60 times 10 times 1.8. When I do all of that, I get 1080.
I can't, I'm doing work right now, Mr. Taker.
Okay, so kinetic is 3,000 minus 1080, which is 1920. velocity is the square root of 2k over m. So that is the square root of 2 times 1920 over 60. That ends up being 8. And finally, the last one, this is the easiest one because D is right on our height equals 0 line, which means that the potential energy is 60 times 10 times 0, which is 0. So 3,000 minus 0 is 3,000 for the kinetic energy. And finally, the velocity is the square root of 2 times 3,000 over 60, which is 10. Note that the velocities at each point do not actually depend on the mass of the cart. If we were to do this with a different mass, although we get different numbers for the energies, we would not get different numbers for the velocity.